Okay, and welcome to this new video in the Pure 1 course where we're going to look at a very important topic called integration. And it is almost like when they say two sides of the same coin. Differentiation, integrations are two sides of the same coin, and you as students being able to understand the rules of integration forms the basis of all A-level integration techniques from now on. So it's very important that we understand the basic rules before we start applying integration. So what is integration? Well, integration is the reverse process of differentiation. And if you remember when we differentiate anything, ax to the n, when you differentiate it, the power n comes down and you subtract 1 from the power of n. Okay, so if you had, remember, x squared, that would differentiate to 2x to the 1. Okay, so integration is the opposite process. It's about going from the derivative back to the original y equation. Okay, and the general rule is written here: increase the power by 1, then divide by the new power. It's a really simple rule. Okay, it's in the notes in your workbook. Okay, and here it is. So the symbol for integration as well is really important. So I'll just zoom in a little bit. Okay, the symbol for integration, I say, is very important. This symbol here is what we call summation symbol. For this level of A level, you don't need to know exactly what it means, but when you come to do areas, you understand. But essentially, you need to write this when you're about to integrate an equation. And when you integrate your equation, you then also have to write dx to say that you're integrating with respect to the letter x. Okay, and here is the rule being played out. You got to increase the power by 1, so whatever the original power is, add 1 to it, and then divide the whole expression by p plus 1. You then also got to add a plus c, and I'll come to this reason later on, but essentially when we integrate from a dy dx back to the original, so if I think about this carefully, even if I had x squared plus 2 or x squared plus 3, that would still differentiate to 2x. And so integrating 2x will give me x squared, but the plus c means that I could also have minus 1 or plus 2. Yeah, it doesn't really matter. So the plus c makes sure that I have that unknown variable accounted for. Now, much like when you differentiate a number, it disappears. Doesn't really nothing happens, well, it just goes away. The reason for that is obviously you got x to the power 0, and we differentiate anything with x to the power 0, the 0 comes to the front, you get 0. So when you integrate a number, then integrating a number will get you kx plus c. Okay, so remember, if I had if you differentiate something, you get a number left at the end, and that must have meant beforehand it was 3x. Okay, but we also have plus c. And these are what we call general solutions. General solutions are such where we don't know the value of c. And where we do know the value of c, or where we have to find the value of c, those are what we call particular solutions. So let's go through the basic rules of integration, and how do we lay things out in order to get all the marks. So this question is saying find this. Now, when you see the symbol, it basically means find the integral of this equation with respect to x. Okay, so this elongated s means integral of this equation with respect to x. You then write an equal sign, you then add 1 to the power, and you divide by that new power, and you add plus c. And that is it. That is the integral of that x cubed. And how can I check that this is correct? Differentiate x to the power 4 over 4, and you get back to x cubed. So question 2. X to the power 4 plus x. Well, I'm just going to write that x as x to the 1. You then add 1 to the power, divide by the new power, and you do the same thing here. Add 1 to the power and divide by a new power. Okay, and you have the plus c there. Okay, and again, how can I check that that's correct? Because if I differentiate x to the power 5 over 5, do I get x to the power 4? Yes, I do. Differentiate x squared over 2, do I get x? Yes, I do. Okay. Now, of course, another way of writing, you don't have to write over 4 if you don't want to, over 5. You can write it as a quarter x to the 4 plus c. It's completely up to you. They're equivalent in terms of what they're getting you to do. Now you've got 2x squared dx, so they're asking us to find the integral of 2x squared. So again, you add 1 to the power, divide by a new power, plus c. Again, how do I check that's correct? Do you differentiate? Do you get exactly back to 2x squared? Yes, you do. And we've got here x plus 1, x plus 2 dx. Now, it's impossible for you to integrate this on its own. You've got to get it into index form. An index form is something like this. It's a really simplified form where you've got the index or the power clearly established. At the moment, this is a double bracket expression. We need to expand the brackets. When I expand the brackets, I'll get this, and that is a simplified index form which I can now integrate. So I'm going to integrate, add 1 to the power, divide by a new power. This is 3x to the 1, add 1 to the power, divide by a new power. When you see a number on its own, imagine that's 2x to the 0, so it becomes 2x to the 1 over 1, which is just 2x plus c. Okay. Now, one thing I'd like to make sure you all understand, the layout has to be very strict with integration. Once you are about to integrate, you keep these symbols here and dx. Once you've integrated it, you don't write the symbol or dx anymore. You have to make sure that you write your final answer plus c. Okay? It's really important that you can practice this rule at this level. So at the bottom of this page, you've got some textbook questions that are well worth having a go at. I would highly recommend you doing a lot of practice on this, as integration does feature quite regularly during the A-level course. That's the end of the video.